He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
They say life is stranger than fiction.
But if you start squeezing lithium down, lithium sort of joins with its neighbor into like a lithium 2 subunit. And so it becomes actually a dilithium solid.
But sometimes what we see in movies or read in books is so incredible that it obviously couldn't be possible. Or could it?
Tesla, I'm sure you know the car company that's working on electric cars. There was a claim that the newest ones will be able to go 1 million miles before needing to be replaced.
Welcome to Sci-Fi Sci-Fact. I'm Brian Crump, and this is a podcast where we take science fiction's strangest ideas, weirdest elements, most unfeasible plot drivers, and explore if they could actually happen in real life. Maybe they already have. And in every episode, we bring in a scientist from New Zealand's MacDiarmid Institute to explain the theories behind some of fiction's more fantastic flights of fancy, if any theory exists. It turns out you can change the law of physics. In this episode, Dr. Krista Steenbergen, MacDiarmid Institute Associate Investigator and Physics Lecturer at Victoria University of Wellington, gives us her take on the dilithium crystals that power Star Trek's Enterprise.
Scott to Captain.
Kirk here.
I've got bad news, Captain. The entire dilithium crystal converter assembly is fused. No chance of repair. It's completely unusable.
No chance of restoring warp drive?
Not without dilithium crystals. We can't even generate enough power to fire our weapons.
Kirk out.
Delving into exactly what it is, I think within the series itself, at least from what I have been reading up on. So they talk about something to do with a material that keeps matter and antimatter separated, and this somehow does not allow annihilation reactions to take place uncontrolled, and then because of this, it sort of it gives some stability around this type of reaction. But in reality, what I understand is it never quite delves into exactly how it produces the kind of propulsion that it would be needing in order to do hyperdrive.
Because,
so,
Krista,
yeah.
I mean, to be perfectly frank here, you are changing the laws of physics to go faster at the speed of light, aren't you?
Yes, absolutely. There is...
Big time.
Yep. You unquestionably would... need to be in a universe that we either don't understand or one that we don't live in order to make that happen.
Okay.
And,
We'll set that aside. We'll set that aside because otherwise that's the end of the interview. But, okay, matter, and I need to ask you another question. Matter and antimatter, another thing you often hear in science fiction, matter and antimatter. And antimatter, it actually does exist. That's a real thing. We know it exists?
Absolutely. Yes, it is a very, very real thing. We can play around with it in particularly particle accelerators. It is a thing that if you collide matter with antimatter, the big one would be electron and a positron. You collide them, then you get an annihilation and a large amount of energy given what you put into it. Or you can do the opposite, where you can take energy, and in under certain conditions, you can actually separate out electron and a positron, so matter and antimatter.
Dilithium is this element that, because I'm pretty sure it's an element, I think, in fact, there is a Star Trek episode where it's mentioned as number 87 on the periodic table, for heaven's sake.
Yes.
So
yes,
it's an element. It allows you to have antimatter and matter not colliding, not having some kind of... You can control the reaction between the two, and that creates the energy that allows you to go faster than the speed of light, which, of course, requires us to change the laws of physics, which can he do, but never mind. So what is element 87 in the periodic table? It's not dilithium, is it?
It is not. It is not. It is, I have to be careful. I would say francium, but it might be francium. But it is an actual element that does exist and was discovered actually before they made this claim of dilithium. And it is highly radioactive. There is a tie back to some chemistry. So the creators of Star Trek were not completely off script, I guess you'd say, when it comes to physics and chemistry when they chose element 87, because it actually shares valency with lithium itself. And valency would be a chemical kind of composition. And so naming it dilithium, but making it sort of a radioactive element, so quite heavy element, probably would have been, I guess, a tie between, looking at heavy elements such as uranium, plutonium, which we at that time would have known that you could split to create enormous amounts of energy, and then putting it as a in the same valency as the straight lithium, the smaller element.
Valency is what the makeup of the outer shell. Sorry, I just banged the microphone there, trying to imagine in my mind's eye the outer shell of an atom. Yes.
And so it generally, it's tied to chemical properties. So in general, to describe it, particularly to lithium, the valency of lithium is that it has sort of a core. Lithium is element number 3, so not element number 87, but element number 3, and it has 3 electrons surrounding its nucleus. And in general, when you look at this chemically, 2 of the electrons form a stable chemical electron shell, and then there's this 1 electron that sort of sits out, and that's its outer valency is that 1 electron. Element 87 has a much larger core of electrons, so 86 of them would form this sort of chemically stable core shell, and not nearly as stable in a lot of ways as number 3, but the 86 electrons would form this, and then it would have this 1 electron as its valent shell.
If I was to look down the periodic table, Krista, I was to look down that periodic table, would I find that francium, which is element number 87 and which in Star Trek is called dilithium, is in the same column?
It is in the same column. That's exactly correct.
And lithium, of course, is a very real element. As you said, it's number 3. It's quite a common element. In fact, is associated with batteries, isn't it?
It is very much associated with energy. And I think back when they would have made this claim, lithium batteries would have been possibly in the development stages. They certainly would have been considered. But since that time, so I think the first episode where dilithium, Star Trek, was mentioned was, I'm looking this up, was 1966.
The year I was born.
Oh, fantastic.
Yeah.
Great year.
I was born the same year as Star Trek. Were you born on that year too, Krista?
No, I was not, but 10 years later. So, the years that end in 6 are fantastic.
Yeah, they're wonderful years. Yep. Sorry, that was a bit of a tangent. I'll come back to what you were saying, which was?
So the 1966 episode, lithium batteries really started to move into development stages in the 1970s, really, and at least where they started to be worked upon seriously. And yeah, they're very, very real energy sources. Actually, they are at the forefront of our energy storage capacities in the current world. So I was actually doing a little bit of reading in prep, and I don't know how seriously to take this at this point, but Tesla, I'm sure you know, the car company that's working on electric cars. Electric cars are a big user of battery technologies for obvious reasons. And there was a claim made in September of last year that the new work that Tesla has done with some researchers on lithium-ion batteries make the claim that the newest ones will be able to go 1 million miles before needing to be replaced.
Really?
And so it's,
that's a few trips between Auckland and Wellington.
Exactly. It's pretty phenomenal breakthrough, actually. So those technologies have been moving very quickly because back when battery technologies first came on the forefront, there were a lot of issues, and then lithium-ion has pretty much smashed a lot of those limitations. It was actually something that was interesting also, I forgot to mention, was it was the chemistry Nobel last year was for the work on developing the lithium-ion batteries, because it's made such an incredible difference in our world.
It's quite possible then, from what you're saying, that the makers of Star Trek knew about lithium then and its potential as a source of stored energy, or a way of storing energy efficiently.
It would be lovely to think about it in that context. The other thing that, you know, I would need to do a lot more reading and probably talking to folks, but the other thing that is actually interesting to think about, and something that I quite appreciate, is that sometimes science fiction actually can drive forward science. And so it would also be cool in a completely different way if the folks sitting back who are doing research happen to be watching Star Trek, and it just planted a little seed, and then they're like, lithium.
Why is it?
We should look at that. So.
Why is it, Krista, that lithium is so good as a material for a battery?
I think a lot of different reasons, and it's taken a lot of work to get there. So it's very light. It's the lightest metal, actually. Also, because of this valency that we talked about, it quite likes to give up its electron, and that is integrally necessary to get power from batteries. And so, in general, the lithium itself, I think both because it's light and then it very much likes to give up its electron to form the current that comes out of a battery, would be reasons that it has become one of the primary materials. There were a lot of issues with it early on. So 3 gentlemen got the Nobel Prize for 3 different stages of development. And it was only in the 3rd stage of development where they finally fixed a lot of problems. Lithium is extremely reactive. So that was one of the big limitations for a lot of years, was the fact that if you just simply have lithium with water, you actually get a quite spectacular reaction. Well, depending on how it's bundled. So if you just have a lithium sheet and it's flat and you put it in water, it just simply sort of dissolves and forms hydrogen gas. But I was actually looking on YouTube. There's some quite spectacular reactions where you kind of bundle the lithium sheet up so that it creates a little bit more like a ball, and you put that in water. It actually starts flaming and creates this, nice, beautiful sunset-colored flame.
Oh,
and,
lovely.
Yeah. And then enough energy that the gentleman doing the experiment burned through his glass Pyrex bowl. So it created some. Yeah.
And then burnt the lab down.
Yes. I'm fairly certain that could be a byproduct. This person was actually doing this in the street. One of those YouTube science folks who put out the information.
And at room temperature, is lithium what your typical shiny silver metal as a sheet?
Yes, yeah. It's actually at room temperature. It would be. I mean, it can be in a sheet form. It cuts quite easily. It's very soft, and so you can actually cut it with a knife. It is a metal, and it's very odd to think about being able to cut a metal with a knife, but you can. And but yeah, it's just it would be metallic, your typical looking metal. Inside these lithium-ion batteries, the ones that would be AA. It would be a lithium compound, and I would need to look up what it would be, but it would be lithium, in some kind of a compound form.
It's much better at building up a charge and storing a charge than other salts or ions.
In general, I wouldn't say necessarily better. I would say that there's a lot of benefits to it. So if you were to compare it to, say, a nickel-cadmium battery, which were the ones that... So, okay, first of all, rechargeability. So this would be something that we care about in today's day and age, where we try to be less wasteful and more environmentally friendly. And so we would like something that we can discharge and then recharge. And the really beautiful thing about the development with the lithium-ion batteries, but I will also add in the nickel-cadmium batteries, is the fact that they allowed this cycling. So you could discharge and then recharge. And it was based on the materials that we were using for the cathode and anode, and the reactions that were taking place at the electrodes of that battery.
I was talking with somebody else the other day. I can't remember who now, but it was about hydrogen. And if you put hydrogen under enough pressure, it forms a solid. And as a solid, it is a superconductor. I think that's been proven, or maybe it's just in theory, because it's pretty hard to create solid hydrogen. I think it's been proven. Now, what happens, say something like lithium, if we put it under some kind of tremendous pressure, might that change its behavior to make it even more like the dilithium of Star Trek?
So it absolutely could, and it does change its properties very, very significantly. Whether it could make it perform as a hyperdrive, probably still far more testing needs to be done and quite doubtful, but it absolutely does. So the really, really interesting thing about lithium, or one of the interesting things about lithium, is the fact that in its standard pressure and temperature, so room, the world we live in, lithium actually exists as a solid. It is a metal, and it has a crystal structure, so the atoms within that material arrange themselves it's a typical to a metal. It sort of packs, the atoms arrange themselves so they're about equally distanced from all other atoms, and so it's called a body-centered cubic structure, and each atom is sort of independent. There's obviously interconnectivity, but it's independent. But if you start squeezing lithium down, it actually turns out that the structure changes so that lithium sort of joins with its neighbor into an Li2, like a lithium-2 subunit. And so it becomes actually a dilithium solid. And that Li2 subunit has completely different properties than the lithium atom where we originally started.
A dilithium solid. Dilithium, just like dilithium in Star Trek. Can it separate matter from antimatter?
I think that is yet to be proven. It's not completely unfeasible, probably far beyond what they've tested at this point. But based on some of the chemical changes that do occur when you put it under pressure, there's a high probability that it becomes less reactive, that's for sure. And so when you take a look at lithium solid being this super reactive, you can't put it in, it reacts within air, it reacts within water. Once you squeeze it down and it forms these sort of lithium-2 subunits, the dilithium subunits, it is very reasonable that it would become a much less reactive solid, somewhere above the pressure needed to create synthetic diamonds and somewhere below the pressure that you would get in the inner core of the Earth, but very, very enormous pressures. The problem becomes that actually looking at what happens with the crystal structure under those enormous pressures becomes very difficult. So the experiments can be done. They do observe the properties that they can measure for lithium. They observe quite a drastic change in those properties. So one of the things they can measure is conductivity. And so when they start with the normal sample that is not under pressure, they can tell that it is quite conductive. It's a metal, so it conducts electricity very easily. And then once you squeeze it very, very tight at approximately 100 gigapascal, it makes this transition to where it is no longer conducting, and it has properties that are much more like what we call a semiconductor or a insulator, except for under certain conditions, I would say.
Right.
And so
that sounds not so useful for energy transfer, but maybe more useful for computational purposes.
Yes, it could be. It could be computational purposes or, any kind of gadgetry that you might like. Yes, very much so. Probably depending on what its band gap would be, because this is the property of semiconductors that make them useful, possibly not even useful in those kinds of capacities, but definitely doesn't seem to be so useful as an energy generator, at least as of yet. But then we go back to within this hyperdrive technology that they were proposing in Star Trek, in theory, it was the separation of matter and antimatter that was making the difference. And so, I think that's still probably, who knows what that could be.
Thanks for listening to this episode of Sci-Fi Sci-Fact, hosted by me, Brian Crump, produced by Andrew Robertson, and of course, made possible thanks to the incredible knowledge of those brilliant scientists at the MacDiarmid Institute. You can find more episodes of Sci-Fi Sci-Fact on the RNZ Podcasts page. RNZ Podcasts are also available on Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or pretty much wherever you might find your podcasts. And make sure to follow us so you don't miss out on any new episodes.